Hello, my name is Kaan Erbay and I am electrical engineering student in Bilkent University, and this video is about our course project, which is the name of the course is Foundations of Magnetic Resonance Imaging. And in this project I researched and learned an MRI technique which is called CAIPIRINHA. CAIPIRINHA's extension is controlled aliasing in parallel imaging results in higher acceleration. CAIPIRINHA is parallel imaging technique which is used 3D abdominal imaging and a data acquisition technique which is reducing the breath-hold without affecting the resolution of images and contrast. CAIPIRINHA also a method to control aliasing and optimize the use of coil sensitivities. Modified aliasing results in improved parallel imaging recon conditions and so supplies a better image quality. Here's an example of liver imaging in 5 seconds of breath hold. In this picture we saw the liver. For CAIPIRINHA, an amount of K-spaces sampling patterns are used for decreasing pixel aliasing and overlap on reconstructed images. The points that are acquired in K-space are shifted from one another by applying more offsets to the phase encoding gradient tables. CAIPIRINHA has some features and benefits. Let's talk about some features. CAIPIRINHA is dedicated sampling pattern to distribute K-space points are more uniformly. And in CAIPIRINHA there is improved algorithm for reconstruction of datasheets. Also, as I mentioned, there is some benefits of CAIPIRINHA. For example, single-digit breath holds are possible in for 3D T1 exams, and higher SNR enables higher spatial resolution, and higher PAT factors are enabled with perfect image quality. Now I'm gonna give some examples, actually 3 examples of K-spaces filling patterns for parallel imaging sequences with R equals to 4. Our readout direction will be into the screen, and the red circles represent acquired data points, and the white circles represent missing data points that must be estimated from the known red points during reconstruction. Our first example about acceleration in a single direction, R equal to 4. Here is the image. We can see red and white circles. In this figure, acceleration is performed along a single direction, which is Kz, with every fourth line data is taken. This example may cause increasing on the noise and residual aliasing artifacts. Now, I'm gonna show my second example, which is acceleration in 2 directions. Here is the image. In this figure, the acceleration is split between 2 different directions, which are Ky and Kz directions. Every other line of data has been skipped in each of the 2 phase encode directions. The total acceleration remains at 4, which is R equals to 2 times 2 equals 4. And my last example is CAIPIRINHA pattern with acceleration in 2 directions plus phase shift of alternate rows. Here is our third image. In this figure, CAIPIRINHA pattern of R equals to 2 sampling in each phase encode direction. There is a phase shift of data sampling in the middle column, and also every fourth column there is a phase shift of data sampling. This phase offset is improving the accuracy of the reconstruction and also reducing noise and aliasing. There are still aliasing artifacts, however, these artifacts are moved to the corner of image space. Today, the most general use of CAIPIRINHA technique is for 3D liver imaging, where highly exaggerated and perfected quality images can be taken during passage of constructs. Now I'm gonna give some different types of breath-hold images and how they look like. In the left, 0 and 4 second breath holds, and in the right, 2 and 6 second breath holds can be seen. Also, CAIPIRINHA is combined with 3D T1 wipe technique, and this allows for spare and spectral FS, or 3D Dixon for contrast in phase, opposed phase, fat and water in a single short breath hold. I present my research, which is CAIPIRINHA technique. Thank you for listening.